All right, welcome to section 1.2, graphs and functions here. We're going to start off with section 1.2 has to do just with lines, and you've done lines all the way since Algebra 1, so there's really nothing new here, just a lot of good review of how to find slope, what is slope, and how to get a general equation of a line. All the good stuff, quite a few things for you guys to know from this section. There's 6 things. So find the slope, write the point slope form, write the intercept form, slope intercept form. Again, recognizing horizontal vertical lines. What's the general form of an equation? And finally, how do we think about and write equations of parallel perpendicular lines? So let's begin. By definition, linear equations they're called. They're just called straight lines. So whenever you have a straight line, technically you have yourself it comes off of a linear equation. The important thing about a linear equation is usually the slope and the y-intercept. That's the main 2 things that we really think through. And you have 2 different kinds of slope. You got a positive slope, which means the line is going up left to right. And this is the way we read graphs. We read graphs just like a textbook. You have to go from the left-hand side to the right-hand side. Then you say, what's happening with this line? So this line technically is increasing. As we look at this graph from left to right, notice the graph is decreasing, so we say this is a negative slope. The equation to a slope, and notice it actually says non-vertical lines. Non-vertical lines have an undefined slope, or we say sometimes a no slope. But let's go with it. The notation for slope, it comes from the French language for steepness or steep or pitch in a sense. From the French language here is the first letter, so we just adopted it into our language as well. So M is rise over run. Technically what it is, it's the difference between the y coordinates and the x coordinates. So sketching a graph that passes through these 2 points, and again you're going to find where 1, -1 is right there. 3, -3 is right there. And you're going to graph a line going those. And don't forget to put arrows at the end, because a line never stops. Remember from geometry class, a line is a segment that goes on forever, right? So you have to put arrows at both ends. If you put only arrows at one end, that means you have a ray from high school geometry. Hopefully remember that. If you put arrows on both lines, both sides of a line segment, now you got yourself a line. So yes, you need arrows on both sides. Alright, and how do we compute the slope of this line? So let's go with that. We're going to use our formula, rise over run, and again it's the change in the y coordinates over the change in the x coordinates. And really all you have to designate is which one's your first point, which one's your second point. So if we designate P to be our first point, this is technically x1. This is y1. This is x2, y2. And really what it's saying is x coordinate second point, y coordinate second point. And you're going to plug them in. And I think you fairly know this fairly well here. So 3 subtract a -1. You're going to then add 3. And 3 subtract 1. I'm sorry, you're going to add 1 to make a 4. 3 subtract 1 is a 2, and then you divide to get yourself a value. So what does a 2 mean? What does that really mean? And it means that for every increase, or 2 increases the y value for every 1 increase or unit increase of an x value. So that 2 in any arbitrary point. If this is 5 and it increases up to, again this is not drawn to scale here. I'm sorry, if it's at 4, increase up to 5. We should see there's an increase of 1 here, and again not drawn to scale. Let's say 3 here, and then we're going to go to 5 here. So notice for every 1 increase along the x-axis, there's an increase of 2 along the y. That's technically what a slope means, or the steepness of a graph. Alright, real quick here, some main facts you should know about slopes. You always look at a graph from left to right. Lines with positive slopes should be going up. Lines with negative slopes should be going down. And then we talk about steepness. Steepness really doesn't refer to going up and down. Steepness is just the how fast it is going up or how fast it is going down. So if you want the steepness of a graph, it's the absolute value of a graph of the slope. Number 3, the slope of the vertical line is undefined. Some textbooks say it's a no slope. So you'll see that sometimes. When you say no slope, what they really are saying is undefined. You got yourself a vertical line. Slope of a horizontal line is 0. It's not going up, not going down. It's just really flat coming across. All right, and the first equation we're going to get to, there's going to be a lot of them here, but this is called the point-slope form of a line. We use this in order to get the equations of lines. So if you can tell on the graph, if you can figure out a point that the line is going through, and you can figure out the slope of that line, you can get yourself the equation of that line. Notice it is something similar to a slope formula. If we divide both these by x minus x1 and put on this side, you're going to get yourself slope. So it really is derived from the slope formula. Alright, so find the point slope form of the equation. A line that passes through 1, negative 2 has a slope of 3, and it's just a straight plug-in of terms here. So you have to figure out what's your x1, what's your y1, and your slope, and you plug it directly into the formula. This is kind of cool though, because you figure 1, negative 2, I know the line passes through this point, and I somehow have figured out that it has a slope of 3. Well, just by figuring that point out and somehow figuring out the slope of this line, I get the equation. So we plug it in. Subtracting a negative, same thing as adding, so we can go directly to here. You have to distribute the 3, and normally the way we want to write it is in slope-intercept form, and I'm sure you guys have or know what slope-intercept form is already. Alright, so this is one type that we usually get. One type is if you know the point and you know the slope. There's another type that we have to wrestle with, and the question is, what happens if you just know 2 points? Somehow you figured out, I know this graph goes through negative 2, 1, and then I also know I figured out another point, it goes through 3, 7. Can you still get the equation of the line? Yes, except there's an intermediate step that needs to happen. We still need a point and we still need a slope. So if I have 2 points, can I get the slope? Absolutely. All we do is we plug it to slope formula. So there's an extra step we got to do if we don't know the slope. We use the slope formula to get it. So how about 7 subtract 1 on top makes a 6. 3 subtract a negative 2. That becomes plus plus. Therefore we're adding. You get yourselves a 6 over 5. That is our slope. And the question is, if I have this point, negative 2, 1, and I have this point, 3, 7, and I have a slope, now I have 2 points and a slope. So which point do I use to solve the equation? Answer, it doesn't matter. You can use this point because this point is on the line. You can use 3, 7 because this point is on the line. Which one's preferred? I think most students prefer the one that does not have negatives, and that's going to be this last one. So let's use this last one, 3, 7. So I don't have to deal with the negatives there. So plugging it in, let's see, 7 goes in for y1, 3 goes in for x1, and the slope is 6/5. At this point, yes, you got to distribute the 6/5. Here it's going to be 6 times 3 is 18 over 5. And yes, we're going to try to solve for y. So if I add 7 here, got to do a little bit of work along the side here. So negative 18 over 5 plus 7. Good common denominators here. So that stays as a 5. I get a common denominator of 5 here. So how about 35? And 5 is here. Negative 18 plus 35 will then give us a 17. So there's my final answer for that one as well. All right. Let's give one more example here to lead us somewhere here. Find the point-slope form of the equation with the line with a slope of m. So now instead of plugging in values, we're going to plug in arbitrary variables here. So really the question is this. If I know this graph goes through a point called 0b, and I know it has a slope of m, is there a way to still set up an equation for this? And absolutely. So we plug in m for our slope, we plug in 0b, and lo and behold, x minus 0 is still x. We add the b over, and there's our sort of, we call it a general form of an equation, or we call it the slope-intercept form of the equation. That's the one we use actually to graph, if you remember. This is so easy to graph because when you look at the graph, when you look at this equation, as long as you know b, and as long as you know the slope value, the m value, you can graph it right away. So let's try one. Slope-intercept form, there it is. I'm sure you've seen it 1,000 times already in math class. And here's what we use it for, because it is the fastest way to graph. We look at this here and we say to ourselves, 2 is where it crosses the x-axis right there. And the slope here actually helps us to get to the next point. And since this is the difference in the y values, this is the difference in the x values, all we got to do is we're going to go 2 up, and we're going to go 3 across. Alright, and then let's take a look at the equations for vertical lines and horizontal lines. First, the horizontal line, y is equal to k. If you are to graph on a coordinate plane, but the x is missing, you know that's going to be a horizontal line. And so it comes across this way. Vertical lines, equations for those are when x is equal to something. So in this case, it's a graph of a line that looks like that. Alright, of course, let's do some examples here. Two examples here. So y is equal to 2. You should pretty much have memorized by now. If you see this, you got yourself a y is equal to 2 all the time. So it's going to cross the y-axis at 2. And technically what you're saying is you have a 0 slope. You're going 0 up or down, and you're going to come straight across to get to the next point. Another way to write this equation, if you really wanted to see, it would be something like this. And see if this makes sense. Isn't that the same thing? Technically you have a 0 times x, that's why the x disappeared in the first place. And if I make this into a slope form, that means there's 0 changes to the y value, and there's a change of 1 to the x value. So then you go 0 up or down, 1 to the right. 0 up and down, another 1 to the right. And then there's your line eventually. Okay, for the second one, x is equal to 4. That one, you do have to memorize that at this point. So you're saying that x is always constant, x is always 4. And then here what you're saying, it doesn't matter what the y value is. So if you want to even make yourself a little table, that's kind of me. This says that x is always equal to 4, doesn't change. The y value, if you want it to change, you can change. A whole bunch of values there. In fact, they're graphed right here. 4, 0, 4, 2, 4, 6, 4, negative 5. And it's a vertical line. And again, vertical lines have undefined slopes or no slope. Alright, now let's look at the general form of a line. General form of a line is x and the y and the constant are all on the left-hand side, and it's set equal to 0. And that's what we're going to work with next. So find the slope, the y-intercept, the x-intercept of a line with the equation of 3x minus 4y plus 12 equals 0, and then also we're going to sketch it. So again, if you're going to graph it or you're going to sketch the graph, you want to solve for y. You want to put it into this form here. That's the way we normally graph lines, and the easiest way to graph lines. So looking at this here, let's move the 4y over to this side, and then since I like the y to be in front or on the left-hand side, I'm going to flip them over. So really there's kind of 2 steps here. What they did is they made it like this, and then they switched the 2 sides around. All right, divide by 4 everywhere. 3 is not divided by 4, so it stays, but 4 goes in 12 3 times. So there it is. I'm ready for graphing here. But let's do a few more things here. We are trying to find the slope. And again, the slope, since we already put it into this form, it's mx plus b. The slope is going to be whatever is multiplying the x. In this case, the slope will be 3/4. All right, and then we know from this equation, let me rewrite it again here since it's on the previous slide here, 4x plus 3. So the slope comes from here. The y-intercept comes directly from here. It's just the number in the back. It's the b value. The b value is the y-intercept. All right, the only thing that we also would like to find sometimes is the x-intercept. And so instead of using the slope-intercept form to find it, usually what happens is we go back to our original equation. To find the x-intercept, all we got to do is we've got to plug in a 0 for the y value. And so once we solve this, I think we'll be done. Notice that 4 times 0 is still 0, so that's going to disappear for us right away. Let's move the 12 over to the other side, makes a negative 12, divide by 3, and we get ourselves a negative 4. There's where that comes from. So then the x-intercept is negative 4, 0. And I think this is the last example in the textbook here. Oh, second to last here. Just where do we use mathematics? We use mathematics to model things. In fact, we use mathematics to model practically everything in life. The weather, we have computer models that model weather. How much sunrise is going to be in a single day. I mean, all these things. We use math to model as much as we can. Stock market likes to predict things. And there's a mathematical model to everything in the stock market, trying to figure out how to make the money here. But one way to model, or at least one formula here that we're using, is whether we can determine the height of a person based upon the length of their femur. The femur is the longest bone in the body. It's the bone from your hip to your knee. And there it is. The formula is h is equal to 2.6x plus 65. And the femur of Wild Bill Longley. He is pictured on the first page of section 1.2, if you want to take a look at it in the textbook here. And here's what we got here. It goes, his femur was measured between 45 and 46 centimeters. So estimate the height of Wild Bill. All we got to do. So there's two different measurements given. There's 45 inches, 46 inches. All we really got to do, we're going to plug it in. So plug it into this formula here. So 45 goes in for the x. And you got to do a little bit of math here. 45 times 2.6. If you want to do it on a calculator, that's fine too. Add 65 to it, and you're going to get 182 inches, looks like, because the formula is in inches. Then you go to here, 46. You're going to plug that one in. So 46 times 2.6 plus 65 gives you 184.6 inches. Ooh, sorry, I am mistaken here. It was in centimeters. Centimeters, that's what it's given in. Alright, and the only thing is we don't like to see things in centimeters a lot because the English Standard Unit deals with inches. So if you want to, you can convert these to inches by dividing by 2.54. And so he was approximately 71.7 inches to 72.7 inches tall. So right about 6 feet tall, maybe just slightly under 6 feet tall. We got to the last example already here. So let's talk about parallel perpendicular lines. 4 things you need to know about them. Well, 4 lines in particular here. So if you have line 1 and line 2, if they are parallel, alright, we come to parallel perpendicular lines. So the relationship that sometimes exists between certain lines. Perpendicular lines become somewhat important in calculus because you can get a slope of something called a norm line in calculus. So let's go for it here. So we've got 2 distinct lines here, L1 and L2, and you have each of them have slopes, M1 and M2. So how do slopes compare to parallel lines? Well, parallel lines have the same exact slope. So one line have a slope of 3, the parallel line has also a slope of 3. Perpendicular lines, it has, if you were to multiply the two slopes together, they become -1. The way I like to say it, and I think most teachers do it, is something called, they have opposite reciprocal slopes. So if one line has a slope of 3, the perpendicular line should have a slope of -1/3. So notice if you were to multiply these together, 3 times a -1/3, 3's will cancel obviously, and then you get yourself a -1. That's where that comes from. But I like to say opposite reciprocal. And that you can do that real easy here. Change the sign and take the reciprocal and you're done. Okay, and another thing we need to know is if you have two vertical lines, they are always going to be parallel. And if you have two horizontal lines, they will always be parallel. And any vertical line is always going to be perpendicular to any horizontal line, and vice versa. So any horizontal line will always be perpendicular to any vertical line. Alright, so let's do an example here then. We want to get the equation of a line that goes through 2, 8, that first of all is parallel to this right here. So 2x minus 3y plus 6 is equal to 0. That's given in general form. So before we can do anything with it, we have the point that we need. And you know what we're going to use? We're going to use this little thing right here. Y minus y1 is equal to mx minus x1. Remember that one from the first equation? We have the point already. I can plug in the 2 in for the x1. I can plug in the 8 into x. The only things we're missing is the m value. So what we need is we need to go back over here. So I need the slope value of this line right here. And so let's start. So 2x minus 3y is equal to 6. Let's see, move the 6 over, move the 2x over, divide by -3, and I got this right here. So this is the slope-intercept form of this line here. And the only thing I really need out of this is this slope right here. Once I have the slope, then I have all that I need in order to finish off the problem here. So for the a value, the parallel line, that's the slope that I need. And we'll keep on going. We'll go through this again as we do the other one here. So all I need to do now is to plug in into my equation. Here's equation. I don't like the way they did it, so I'm doing a first and then I'll do b afterwards. So y minus 8, because that's the point that we're plugging into. The 2/3, because parallel lines have the same slope. And x minus 2, the 2 comes from here. So there, and slope is because they're parallel slope. Alright, if you distribute this into here, and they don't leave much room here. They did not leave much room over there, so I'm going to finish off the problem right here. So we got 1 minus 8 is equal to 2/3, and x minus 2. All we do is we multiply that in, gives us 2/3 x. Let's see, minus 4/3. And here we want to put it into the general form, because that's what they want to use it as. And so we're going to multiply both sides by 3, and the reason why I multiply by 3 is to get rid of these fractions here. And so that's going to be a 3y minus 24. And as the 3 multiplies into here, the 3's cancel. As the 3 multiplies in here, the 3 cancels with that, leaving us minus 4. And then what we're going to do is we're going to bring everything over here. So minus 2x plus 3y minus 24 is equal to -4. Add 4 to both sides some more. And it looks like the final result is -2x plus 3y minus 20 is equal to 0. Alright, and the only other thing that tends to happen here is, see this little negative in front? You could write it like this. Most textbooks would like the number in front of x to be positive. So what tends to happen, again with most textbooks, is they multiply through by -1 on both sides, leaving us with the final answer of 2x minus y plus 20 is equal to 0. Alright, so hopefully that helped you with, this is example 9, I believe, A. Alright, let's do example 9b over here on this side. And if I run out of room, I'll make a next slide here. So we have this equation. We want now we want the line to be perpendicular to this line and to go through 2, 8. So again, starting the problem all over again. This is example 9. So I'm going to take this and I'm going to solve it for the y value. Let's see, I can subtract 6, bring it over to this side, subtract 2x, bring it over to this side, so I'm left with -3y is equal to -2x minus 6. Divide through by -3 everywhere. Y is equal to 2 over 3x plus 2. Oh. Plus 2. And so now what I want is I want the perpendicular slope, not the parallel slope, the perpendicular slope. So the slope of this line is 2/3. Again, opposite reciprocal. So the slope that I want is going to be the opposite, so a negative reciprocal 3 over 2. And then again, it has to go through the point 2, 8. So now I actually have everything I need. I have a slope and a point to plug it into the point-slope form. So how about y minus 8 is equal to -3 over 2 x minus 2. And again, the directions here, it says write the answer in the general form. So we're going to write it in general form here. Multiplying through. In fact, let me start this on the next slide here. So we got y minus 8 is equal to -3 halves x minus 2. All right, distribute the slope to each side. So it gives me a -3 over 2x. Distribute it to here gives me a, well, let's see, the 2's are going to cancel, right? So -3 over 2 times 2, or 2 over 1. 2's are gone. Kind of careful here because you get a -3 and you also have a negative here, so it'd be a negative, or times a negative is a positive, so just +3. They want the answer in the general form, so let's get rid of any fractions here. Got to get rid of this 2 here. So let's multiply both sides by 2. So 2y minus 16. 2 as it goes into here, it's going to cancel with this 2, leaving in -3x. 2 is going to multiply into here, giving us a 6. And so let's move things over. Okay, still have the 6 over here, so let's subtract that out and finally get a 3x plus 2y minus 22 is equal to 0. And that is the end of the lecture for 1.2.